To scale artificial intelligence globally, current systems rely on massive, centralized data silos. But as data increases, these central structures become a physical bottleneck. Managing global AI demands through a handful of centralized databases is becoming computationally and economically unviable. The overhead required to sync and secure a single core scales faster than the hardware can support. Solving this requires a shift away from the central hub, moving the intelligence and the computation out to localized, highly distributed nodes. Achieving that level of scale requires more than a software update. It requires a new structural foundation that replaces the legacy cloud stack. This foundation is the Aurora Network Architecture. Aurora provides a framework to transition current, isolated AI models into a distributed ecosystem, one that integrates knowledge, trust, and cloud infrastructure into a single environment. The core design principle of this network is the strict operational decoupling of system primitives. Each layer is isolated to ensure it performs one specific function. To understand how this functions, we can map the network by building out its 4 decoupled domains: knowledge, trust and value, authorization, and resources. Building the network through these distinct modules is the method Aurora uses to ensure the system remains verifiable and economically viable as it grows. Looking at the architecture, the process begins at the top with Project Genesis. This module acts as a temporary bridge, transforming current AI training and data into native Aurora knowledge. The knowledge itself is not held in a central repository. It lives strictly in local dictionaries, managed by the individual nodes. This creates a challenge for the network. These localized datasets must be made usable and standardized for the rest of the system to access them. Aurora solves this through fractal tensors. This layer structures local data into a format that is both verifiable by other nodes and reusable across the entire network. This structured data is then indexed in the Aurora Encyclopedium, which acts as the combined abstraction of every local dictionary on the network. It is a critical distinction that the Encyclopedium is an abstraction layer only. It explicitly does not exist as a central database, preventing the bottleneck identified earlier. Structured knowledge alone isn't enough to run a network. The system also requires specific frameworks to manage access, identity, and the exchange of value. These are the perimeter frameworks. On the right, the decentralized authorization directory manages identity and discovery across the network. This directory is responsible for managing public keys, defining what each node is capable of doing, and enforcing authorization rules. It also handles the logistics of the network, mapping the routes to specific nodes and tracking their current availability and pricing. Opposite the authorization layer is Project Covenant. This module establishes the trust and value framework that allows the economy of the network to function. Covenant defines these variables precisely. Trust is a node's reputation based on its history of operations. Merit is the measure of a node's actual contribution, the work it has done for the system. And mind serves as the internal payment unit used to settle transactions within the network. By separating these frameworks, the architecture ensures that identity and money never get tangled with the raw knowledge data. These layers, knowledge from the top and governance from the sides, converge in the network core. This is the central logic of the entire system. The bottom half of this core is the node network. This is the physical layer. It consists of specialized nodes that are physically responsible for creating, verifying, and exchanging knowledge. Above the nodes sits the Aurora Ledger. This is a blockchain that handles the logistics of every exchange. It records transactions, tracks token history, and maintains a strict record of data provenance. The ledger also handles value attribution, logging which node contributed specific intelligence to assign merit. The network core acts as the final arbiter, ensuring that no data moves through the network without being verified and logged by the ledger. When verified nodes interact with the ledger, they produce a functional secondary layer, the Aurora Cloud. This cloud is emergent because it is formed by the combined resources of decentralized nodes rather than the static servers of a central provider. This layer provides 3 distinct categories of resources: raw compute, data storage, and structured knowledge. Aurora routes these resources downward to power applications and user-facing tools. This brings us to the final output of the stack: digital and economic services. This demonstrates that complex AI and economic services can function effectively without being hosted on a centralized server farm. The architecture remains stable because it enforces a total separation of concerns. This philosophy is stated at the bottom of the diagram. Knowledge generation is kept separate from trust and value, while authorization is isolated from raw resources. Legacy networks often fail to scale because these domains overlap, causing the system to become bogged down by its own internal management as it grows. By enforcing these boundaries, Aurora prevents operational overlap that typically leads to bottlenecks in decentralized systems. This shift moves the industry away from isolated AI silos and toward a cohesive, emergent cloud. It links isolated nodes into a single network where intelligence can be verified and shared. The result is a fully trustless intelligence economy, where computational work is automatically quantified and compensated through a verifiable ledger. By modularizing its core primitives, Aurora provides a functional template for how the next generation of distributed networks can manage global-scale AI and digital services.